live session on the topic stack, which is brought to you by Talent Sprint. I'm Deepika. Hope you're all good with and doing well with your preparation for various computer programming tests and interviews. So we are here to help you score good in those tests. So let's get started by knowing one topic on data structure, that is stack. And we'll be seeing in detail about the stack and try to solve some problems. Hi, I can see Yogit and Raj Kiran already logged in. Okay. So now, say suppose you have some books and trying to put it in an order, like one on top of another. Then you take one book, put it, and then you take another book and put it on top, and then you take another book and put it on top, and then you take, say suppose you have 4 books, you have kept 4 books on one another, on top of one another. So this is one type of arrangement. And when we try to remove a book from this pile of books, what do? We take one book, that is the topmost book, and remove it. And then if we want to take another book, then we remove it from top. So say suppose if we want a book in the last, or we want a third book or the last book from this pile of books, what do? We take the topmost books aside and then the third book or the last book, whatever that you want, and remove it. So obviously what we can observe here, and one more thing, say suppose you want to put all these books into a shelf. What do? You generally search for a shelf where you can put these 4 books into that shelf and store. So what do? Generally we take a smaller shelf so that these 4 books are enough to put in. Say suppose you have 50 books or more than 50, like 100 or more than 100. What do? You take a larger or bigger shelf to put those books. So what we have observed here, that is whatever the book that you want to put it in an order, or that is on top of one another, you put on top of each other, on top of one another. That means you put one book on top of the another book, and when we try to take out, you take from the topmost book first, then the second one, and then the third, and then the last. So what structure do you observe here? That is last in first out structure. So the last inserted book will be the first one to receive or first one to come out. So this is a structure that is last in first out structure. And what else do you observe? When we try to put all these books, what else do you observe? That is, when we put or when we take out, it will always be from the topmost book only. So the operations, that is inserting a book or taking out a book, will be from one end, that is the top end. And what else can we observe? That is the storage where we are trying to put these books will be limited, or will be to the number of elements or number of books that we want to store. That means the storage will be limited to how many books you want to put. If you want to put just 4 books, you will search for a smaller shelf, and if you want to put more than 100 books, then you will definitely go for a larger shelf. So the operations that are performed, that are inserting a book and taking out a book, will be in sequential order. So this structure where last in first out principle is followed will be in the sequential process. So we are going to deal with one type of such structure, that is stack. So stack follows a structure like last in first out, where the elements that are stored into the stack will be always from the top end, and the operations that are performed will be pushing an element and popping an element out from the storage, and the storage is limited to the size, or the size of the storage will be limited to the number of elements that you are putting in. So we can observe here that whatever the elements that we are putting in or removing it will be in the sequential order. So this is a sequential processing that will be followed in this data structure stack. So let's move on with an example. Let me share the screen with you so that we can see the example pictorially. Okay, so here we can see that stack is nothing but a collection of elements wherein which it uses last in first out principle, and always the operations like inserting or pushing or removing an element will be from the top end, and the size of the stack is depending on the number of elements that you are putting inside. So there's an example again, pile of books and the stack of plates, where we put all the plates one on top of the another, and when we try to take out a plate, we will always be taking the first plate that is on top. So the last kept plate will be the first one to be taken out. That is the example. So these are the two operations, push and pop, where it will be operated on the element present in the stack from one end, that is top. See here, this is the push operation where we have taken a stack. We have taken a stack of maximum 5 elements. Now here, this top is indicating the topmost element that is stored in the stack. Now initially top is -1. That means what is there in the stack? Have we stored anything in the stack? Nothing. So stack is empty. That is indicated by -1. Now top, if there is nothing inside, that means it stores -1. That indicates there is nothing inside, and the stack of 5 locations is named as 0 to 4. Now when we try to push an element, say 10, what it will do? It will push on to the top of the stack, that is to the 0 location, and then it is indicated as top. Now if we try to push another element, top will become the recently added element, that is 12. Now if we try to insert another element, say 7, top will be indicated to the recent element that is added to the stack, that is storage. Now when we try to add another element, then top is indicating to the recently added element, that is 15. Now if we try to push another element 20, then top indicates to the next location where 20 is being pushed. Now at this point we have to see that we have taken a stack size of the storage size as 5 elements, because 5 locations, because we want 5 elements to be pushed inside. But say suppose now this indicates stack is full. Now if you try to push another element, say 25, if you try to push another element, is there any place in the stack? No, because already stack is filled with 5 elements and the stack size is already defined that it can store 5 elements. If you try to put more, then it leads to stack overflow. So when stack is full and when we try to push another element, then that leads to stack overflow. Now let's see the next operation. Now here we have again pop operation, and again maximum elements that you want to store in the stack is 5, so stack is already indicating that it is full. We have top reached to max -1. If maximum value is 5, then top value, if it reaches to max -1, that is 4, that means we have reached to the topmost element in the stack. Now when we try to pop out, what it will pop? Generally, pop is used for removing. Pop operation is for removing an element. So it removes the element. Definitely it will be from the top end only. So 20 will be removed first. Then if we try to again pop an element, it will remove obviously 15. Then if we try to again pop out, it will remove 7. If we try again pop operation, it will pop the top element, that is 12. And when we try to pop again, it will pop 10. And then if once 10 is popped out, now what is top indicating to? Are there any elements in the stack? No. So top doesn't locate to any location in the stack because there are no elements. So it is indicating as -1. That means there are no elements. Stack is empty. Now when we try to pop, if top is -1 and if we try to pop out, then what happens? It leads to stack underflow. This is about the operations that are performed on stack. Now we have known about stack. It takes last in first out structure and it operates from the top end. Now there is an application on which is based on stack, like last in first out structure, that is calculator. Say if there is any expression given and the data values are given for that expression and the result must come out. Like calculator, when we give an expression with the operations that we want to perform, it gives out the result. How does that happen with the calculator? Basic arithmetic calculator, where it performs the basic arithmetic operations. If you try to give an expression, it gives us the result. Expression in the sense the data values which are given with the operations that we want to perform. So what it will do? It will evaluate that expression, process it, and then gives us the result. How will that happen? And how does it relate to our topic now? Is what we will see now. Generally, whenever there is an expression given, it will be in some order or it will be in some representation. What is that? We will see now. Let me share the screen with you. Now here we can see that expression can be represented in 3 forms. Okay, we can see that there is an infix expression, prefix and postfix. Now what is infix expression? The operators will be in between the operands. That is the infix representation. And what is a prefix? Operators will be in front, that means to the left side of the operands. Operands in the sense A and B, that are values. And postfix expression is represented as the operators will be to the right side of the operands, that are A and B. So this is how we represent an expression. Now generally whenever we try to evaluate an expression, we give in an infix notation or infix expression will be given. How does this infix expression will be evaluated? And how does this postfix or prefix will help in evaluating that infix expression is what we will see next. Now, we can see here that there is an infix expression, simple expression where a plus b into c is taken. Now there are some values, consider there are some values with a, b and c. Now what it has to do, it has to evaluate this and give us the result. How does this evaluation process is? First, it follows whenever an infix expression has to be processed and get the result, it follows some rules, that is precedence. Precedence, that is priority. What is the priority given to the operation? Which operation? See, whenever we see an expression, there are 2 operators. Which operator must be operated first? Which operation must be taken first is what we need to understand. So for that there is priority given to every operator. So here among these two operators, the highest priority is given to multiplication. So multiplication operation will be performed first. So how to convert it into postfix? So when we are trying to convert infix to postfix, how it will look? B into C will be changed to BC, and then your multiplication symbol will be moved to the right side of the operands. So here with one step we have converted one small expression, one operation into postfix. Now we have another operator still. So that also must be converted, so that whole expression will be converted into postfix. So how do we convert that? Next, your operator present is plus. We have already converted B into C, and then there is another operand A. So the operator that is left in the whole expression is just the addition operator. So A will be taken, then the BC multiplication symbol, and then your addition symbol will come to the right side of these operands. So this is how we get our postfix expression. So we convert with based on the operators present, we take steps so that our conversion gives us our postfix expression. So whenever we see or whenever an expression is given, first the whole expression is read or scanned, and then it checks out the operators. Based on the priority given to every operator, the highest priority operator will be operated first. So that will be checked and it will be converted into postfix expression. Once it is converted into postfix expression, it has to be evaluated with whatever values that are present in A, B and C. So that we will see with an example little later. So the first step is BC's, and then multiplication symbol is moved to the right, and then your A and then BC multiplication symbol is considered to be two operands with plus, that is addition operator, moved to the right of these or right side of these operands. So this becomes our postfix expression. Now let us see in another infix expression which is little larger, having more than two operators. See now, whenever infix expression is given, to get the result out, first we have to convert into postfix. So for converting into postfix, what it has to do? It has to scan, that means the expression must be scanned or must be read fully and check out the highest priority operator. Now in this expression we have got multiplication and division with highest priority. So which one must be evaluated or which one must be converted first? Which operation must be converted, whether it should be multiplication or division? And that depends upon the associativity rule. The associativity rule is whenever we have more than one operator with same priority, then it always checks for the leftmost operator or the operator which has occurred first from the left side. So the leftmost operator, highest priority operator which has occurred first is multiplication. So this is evaluated or this is converted first. So what it will do? It will convert this C, D, and then the multiplication symbol will be taken. Now what else? What other operators are left? Plus, plus and division. Among these, which one will be taken next? It will be definitely division. Why? Because these two have got the highest priority. So the first one has already done. So the next which comes into which comes in the expression is division. So what it will do? It will take this value, and then it takes the next value, that is E, and because there is a division operator in between, that will be shifted to the right. So what it will become? It will become C D star, that means the multiplication symbol, then E, and then the division symbol. Now this has become one operand now. Now what else are left in the expression? It is A plus B plus, and the next expression is converted into postfix. Now this is just acting like one operand. This is another operand. This is another operand. Why? Because there are two operators left for conversion. So now here we can observe that there are two operators, same operator, that means same priority again. So if there are more than one operator with same priority, then what it should do? Again, the associativity rule is it must take the leftmost operator. The first occurred operator from the left hand side must be taken, and then the next, and then it goes on in sequence. So what it will do? It will perform the A and B addition first. So A, B, and the plus operator will move to the right of these operands. And what else is left? So this expression is converted. Now this has become one operand and this has become one operand. That means it is acting like an operand, and the operator present which needs to be converted still is plus. So now what it will do? It will take A, B plus, and then the other operand, that is C, D star, that is multiplication operand, E, and then division, and then this plus or addition operator will come to the right hand side of these two operands. So it will come here. Now this is our postfix expression. Is any more operators present in our expression? No more. All the operators are moved to the right of their operands. So this has become our postfix notation or postfix expression. Now how is this helpful for our evaluating or evaluation of this expression is what we will see now. So this is how it is going to convert. First C into D, that means CD multiplication symbol. So it acts like an operand, and then the expression, nothing but CD multiplication symbol is the operation is evaluated first. So the value, it is nothing but an operand. So then division will be taken next, and then whatever the value that has come out for after this multiplication will be divided, and then that means the division comes next, and then the addition operator which has occurred first will be taken, and then the whole of this operand, which is the first one and the second operand, will be again converted into postfix, where it becomes in this way. So our total postfix expression would be looking like this. Now this expression must be, or this expression is needed for evaluating the expression and giving us the result. So to evaluate this expression we need some values to it. So let us take some values. So let us take some values, that is A as 1, B 2, C 3, D 4 and E 6. Now this is our expression which is given. Now to get the result, how will this last in first out structure help? That is, convert this infix expression into postfix. So we have converted it. Now after converting, what you are supposed to do, take these values and evaluate this expression so that you will get our we will get our result. So what is A value? The first the postfix expression will be taken. Now each element in this expression will be checked out. What is the first element? A. A is nothing but an operand value which is 1. What do we do with just 1? Nothing. So we will put it aside. And then what is the next element? That is B. So B, what we will do with B? Nothing, because it is just an operand, so we will again put it aside. That is 2. Now what is there in the next element? The next element in the postfix expression is plus. So plus is nothing but an operation. So here we have to operate something, operate on something. So what are the already existing elements with us? 2 and 1. So what it will do? It will perform addition. So plus has occurred first, so it will perform addition on both. So 2 plus 1 will be changed to, or will be added, and that will become 3. So what do we do with this 3? We will put it aside. And then what is the next element in the expression? C. C is a value 3. So what do we do with 3? Nothing. We have no operation to be performed on that, so we will move it aside. And then next element is D, that is 4. So 4 is again an operand, so we will move it aside. And then what is the next element occurred? That is multiplication. So multiplication is an operation to be performed on the data. So what we have? 4 and 3. So 4 and 3, the next operator that is occurred is multiplication. So 4 and 3 will be removed. The recently added elements are 4 and 3. So the recently moved elements would be 4 and 3. So we will multiply these two. So what it will be? It will be 12, and 3 is already there with us. So this will be our elements present now. Recently added 12 and 3, which is already existing. And then after multiplication, what is the next element? That is E, nothing but 6. So 6 is again an operand. So what do we do with this operand? We will move it aside. That is 6. We will move it aside. Then comes division. Division is an operation, so we have to deal with it. So 6 and 12. 12 divided by 6 is 2. So these two will be divided, and we already have 3. And what we will do? We have got, after division, we have got 2. So 2 will be kept aside. And then what is the next element? Plus. So when plus is occurred, what happens? What are the elements now with us? We need 2 elements and we have 2. So 2 plus 3, that is what? So 2 plus 3 will be added and we get 5. So the result of this expression, when we give values like this 1, 2, 3, 4 and 6, then we get the result as 5. So for evaluating this expression, we have to convert it into postfix, and then we need to convert this expression into postfix so that we can perform using this structure called last in first out structure, and then evaluate this expression using last in first out structure so that we get the result as 5. Okay, I have seen a question from Shama that CD multiplication and then CD multiplication E division. What is? I cannot understand what you want to ask, but I can just show you that. First, this is our expression. So multiplication will be performed first, then this is acting like an operand. So what we do? E will be taken next, and then the division will be moved to the right, considering CD multiplication is one operand and then D is the second operand, and then division moves to the right of these two operands. Okay. So this is what we have seen, that infix will be converted to postfix and then it will be evaluated with the values so that we get our result. Now to summarize, we see that stack is a data structure which stores the elements one on top of the other. So the operations will be performed from one end, and the size of this storage is limited to the number of elements that are kept inside. And for LIFO structure, this type of last in first out structure is used to evaluate the postfix expression. Now let us see few questions and try to solve them. Now here we can see that there is a question given. There is a pseudocode C-like function where it uses a stack to do, where it takes a number as an argument and uses stack to do some processing. And what is the question? This is a pseudocode, and what is the question asked? If n is 5, if the n value, the argument that is passed is 5, what is the output? So let us see. If n is 5, say suppose there is a stack and stack, okay, and then what is the n value? It is 5. 5 is greater than 0? Yes, because here there is a loop. So these operations or these statements will be repeated how many times? Until loop ends or until loop condition becomes false. So 5 is greater than 0, it is true. So what it is trying to do? It is trying to perform a push operation by pushing what value? N, which is divided by 2, and the remainder is being stored in the stack. So 5 is divided by 2 and the remainder, what is the remainder of this when it is divided by 2? The remainder would be 1. So what happens? You have a stack and there is a 1 stored in it. And then what is the next statement? N is divided by 2 and stored in n again. So n is 5. 5 divided by 2 and the quotient. Here the operator is different. So the quotient is taken. What is it? It is 2. So n value is 2 now. What happens? The loop repeats. 2 is greater than 0? Yes. So it enters. 2 divided by 2 and the remainder is 0. So 0 is pushed into the stack, and then 2 is divided by 2 and the quotient is 1. So n value is changed to 1. Now 1 greater than 0? Yes. So it enters. Now 1 divided by 2 and the remainder is 0. Sorry, 1. So what happens? 1 is being pushed into the stack. I can see Ravi Chaudhary who have logged in. Hello Ravi. Okay, now here we have seen that this loop is for repeating what? 2 steps where it finds the remainder of n, and then n value is changed to some other number so that loop condition can become, or loop can end. So now n has become 1 and then 1 is being pushed inside and 1 divided by 2, and what is the quotient? 0. So n value will be changed to 0. Now when n is changed to 0, 0 greater than 0, condition fails. So it comes out of the loop and checks the next statement in the sequential order. Now here there is a condition again, while loop, where it is checking E is empty. What? Stack. So is stack empty? No. So false. Not false is nothing but true. So this loop will repeat until the stack elements are empty. So because we have stack empty false, the condition becomes true. So what it will do, it will pop out the elements until all elements are popped out. So it will pop out the topmost, that is 1, and then 0, and then 1. So what we have received, what is the output? 101, nothing but the binary representation of n value. That is what is our answer. So output of the program would be the binary representation that we get whenever whatever the value of n is. So always whenever there is a question, try to check out each and every step and what is the operation performed, how it is getting evaluated. So let's move on to another question. Now here there is another question. There is an infix expression given, and what is the correct postfix notation? Nothing but postfix expression. So how do we evaluate this? How do we evaluate? We have seen that multiplication and division has got the highest priority. So that will be evaluated first rather than the other operators. So among these three operators, which one will be evaluated first is again another question. So that again follows the associativity rule, that whichever occurs first, whichever operator with the same priority, that is highest priority, is occurring in the first place from the left hand side. So now here this is the operator occurring first, multiplication on AB. So AB multiplication is taken. Then what other operators are present? Minus, plus, minus, and then multiplication, division. Now which operator will be performed next? This one, because the next in sequence the same priority operators are multiplication and division. So among these three, whichever has occurred first is converted. Next, whichever is occurred next will be taken. So what it will do, the remaining operators will be left as it is, and this will be converted. What it will become? E, F and multiplication symbol, and the remaining operators will be again as it is. Now this both are acting as operators, operands. Now what will be taken next? The next one will be taken. This is already finished. So now division operator will be considered next. So what it will do, it will take this as an operand and the other operand as G, and then put this division to the right side. So the expression would be in this way: E, F multiplication, then the operand G, and then the division. So now this has become one operand, this has become one operand. C and D are other two operands with operators minus, plus and minus to be converted. So now which operator will be taken next? Whether it should be minus, plus, or the second minus operation or subtraction operation. So which one will be taken? This will be taken next, because according to the priority, all have same priority. So according to the associativity rule, which one has occurred first from the left hand side will be taken first. So what happens? The operand AB multiplication and C will be taken to the left side, and the operator will be moved to the right side of these operands. And then now this has become one operand. Next, what operator will be performed? Will be converted plus. So what it will do? This has become one operand now, and then D, then plus will be moved to the right. And then now what operator is left? Minus. So what it will do? It will consider this whole expression as one operand and this as one operand, and my subtraction will be moved to the right of this operands. So what it will be? E, F multiplication, G division, and then minus will be moved to the right. So our postfix notation would be this. So the answer would be A, B multiplication, C minus D plus E, F multiplication, G division and minus. This would be our expression, postfix expression after converting our infix expression. Always make sure that you check each operator, scan or read the whole expression and then evaluate or try to convert the right operator first and then move on to the next operator for conversion. Then only we will get the right expression. Okay. Now here there is another question. Wherein which it says okay. See, we have a question that consider the following operations are performed on a stack of size 5. So there is a stack of size 5, that means some storage which takes last in first out principle and which is of size 5 starting from 0 say 2, 3, 4. Okay. So this is our stack say. Now what are the operations that are performed? Push, that is 1 is being pushed and then 2 and then 1. Now if these are the operations performed, what he is asking, the sequence of popped out elements are to be known. So how do we find out the sequence of popped out elements? So if the elements that are pushed are 1 to 1, so it will be 1 to the top and then 2 will be added on top of it and then 1 will be added on top of it and then there is a pop. So pop will pop out the first element, that is 1 will be popped out and then there is another 2 push operations with first 2 and then the next pushed element is 3. So now there is we have pushed 2 and 3. So now what is the next operation performed? Pop. So pop will pop out the topmost 2 elements. Because we have popped out element 1 from here, so what we can understand is 1 present, is 2 location 1 present in the stack? See, there are 5 locations and we have pushed 1, 2 and 1. When we try to pop out, what happens? 1 will be removed. So 1 is popped out and then 2 and 3 will be pushed. So where it will be pushed? It will be pushed to the top location 2 and then 3. And then when we try to pop out, what it will pop out? It will pop 3 and first pop operation it will pop 3 and next pop operation it will pop 2. So 3 and 2 will be removed. So now top will be at which location? At the 1 location. That points to the element 2. Now we have 2 pop operations and then what we have done? We have again pushed 3 inside. So what happens? 3 will be pushed into the location that is 2. So top location is now at which position? Second position where 3 is kept. Now there are again 2 operations, pop. So pop will pop out the first element. So 3 will be popped out and then the next pop will give us 2. So after these operations, what is the sequence of popped out elements? 1, 3, 2, 3, 2. And is stack empty now? No, stack is not empty because there is one more element present here. How do we see that? See, there are 6 push operations and 1, 2, 3, 4, 5. 5 pop operations. So definitely there will be one element present in the stack. So stack will not be empty and the popped out element sequence would be 1, 3, 2, 3, 2. So there is another question where the expression, postfix expression is given to us in this way. Now how do we evaluate this expression? We again go with the last in first out structure, that is, see, there are 3 operands. What do we do with these 3 operands? We will just move it aside, 7, 2 and 6. So last kept will be on top of the another. Now there is an operator encountered. So what it will do? It will operate on the recently added 2 elements. So what it will do? 12 and already existing 7 will be done. Multiplication will be performed on the top 2 elements. So 6 to 12, that will be kept here. Then next, what is the next operator? That is plus. So plus is an operation which must be performed on the data, that is operands. So we have two operands where we are supposed to perform the addition operation. So previously we have done multiplication and then now addition. So what it will do? It will add on the data that is existing. What we have? 12 and 7. So that will become 12 and 7 will be added. So it will become what? 19. Now what is the next element in the expression? 5. So 5 is again an operand. What do we do with that? Nothing. We will just move it aside. And then what is the next operand? It is 6. So what do we do with it? We will just move it aside. What do we do with the next element? 2, which is an operand. We will just move it aside. So 2 will be moved aside. And then what is the next element in the expression? That is division. So division is an operation which must be performed on the data that is existing. So the recently added data is 2 and 6. So what it will do? 2 and 6 will be divided. So we get result 3. So we have 3 which is recently added, that is division of 2 and 6, and then 5 and then 19. Now what is the next operation? Plus. Plus again needs 2 operands, operation to be performed on 2 operands, so it will take 3 and 5. So 3 and 5 will be added. What it becomes? It becomes 8, and already we have 19. So 8 comes on top of it. Now what is the remaining element in the expression? That is multiplication. So what happens when multiplication is encountered? It is going to multiply 8 and 19. So what is the result? It is 152. Any more elements in the expression? No more. So this would be our final result, which will be stored in the stack. When we try to pop out, we will have this element which will be popped out, which is our result. So here are few examples that we have shown. So we have seen some examples and tried to solve them, and hope you have understood how to solve a particular question based on stack and how to convert an infix expression to postfix and the postfix expression evaluation. And this would help us in evaluating an expression and getting the result. Mostly such type of processing will be performed in the calculator application. And this stack or the last in first out structure can be followed even in recursion concept, where number of functions are called repeatedly follows a last in first out structure. And whenever we are backtracking something, we always go for the recently taken step or previous taken step. So for backtracking of some problem, we need this last in first out structure. So this structure helps for us in this data structure to store the elements and retrieve the elements from one end, and the storage size would be limited to the number of elements that you want to store in it. Hope you have understood, and this video or this session is beneficial to you for attempting questions related to stack. Thank you.
Hello everybody, welcome to Talent Sprint. My name is Sarmishtha and here's your daily dose of job skills. In today's video, we are going to learn about the 3 basic steps that you must follow when you go for a personal interview. So at the end of the video, you will learn what are the 3 things you must definitely do and what are the 3 things you must prepare to go for a personal interview. The first one is prepare. Now under preparation, what do you really prepare for? The first thing that you prepare is...
I'm Akshita Kashapur from Belgaum. I'm Nitika. I'm from Andhra Pradesh.
I'm Aravindan. I'm coming from Salem.
My name is Smita. I'm from Bangalore.
My name is Saurabh Singh. I am from Delhi.
My name is Sukriti. I completed my engineering from Bhopal, Madhya Pradesh.
I'm Megha Vikumar from Bangalore.
Sonam Singh from Hyderabad.
I'm from Tirunelveli.
And I'm from Aurora's Engineering College.
After I took